right, let's solve this problem. Water is draining out of a conical tank at a constant rate of 120 cubic inches per minute. How fast is the level of water in the tank decreasing when there are 7 inches of water in the tank? The radius of the tank equals 7 inches and the height is 28 inches. Now add that to your notes. That had to be added in because they forgot to give us a way to determine the relationship between the height and the radius. Is this a tall skinny cone? Is this a short fat cone? I don't know, but now we know. Identify all the variables involved in the problem. R is radius. H is height. V is volume. And none of these remain constant. Let's identify the rates we know and the rates we wish to find. We're given dV dt because it says that the water is draining out of the tank, out of a conical tank. So that would be 120 inches cubed per minute. And since the water is draining, our derivative is negative. We are looking for dH dt, which means we need to rewrite the radius in terms of height. Right? Because otherwise we would have too many variables and not enough rates. So the radius is to 7 inches as the height is to 28 inches. We could reduce along the bottom there on the denominator. And so 4 radiuses equal 1 height. We want to replace radius because we need the h dt. So the radius is equal to the height divided by 4. And there we go. So we are going to replace radius in the equation for the volume of a cone by height divided by 4. So let's write our equation. So I'm going to actually scroll this up a little bit. Maybe that far. All right, so volume equals 1/3 pi r squared h, and we're replacing r with h over 4. So volume equals 1/3 pi h over 4 times squared times h. Let's simplify that before we take the derivative. So this is 4. We're just writing the equation here. Let's square. Volume equals 1/3 pi h squared over 16 times h. Let's combine the 3 and the 16, and let's combine the h's. So volume equals 1/48 pi h cubed. Now we've got it down to only one unknown rate, and so now we can take the derivative. So now we're on number 5. We'll take the derivative with respect to time. dV dt equals 1/48 pi. This would be the power rule. The 3 would move in front. And pi, by the way, the 48 and the pi are just a coefficient in front of our variable. And then the exponent reduces by 1. Let's clean that up. Oh, and then don't forget dH dt. Right? We have to take the derivative. This is an implicit differentiation. We take the derivative with respect to time. So dV dt equals, so we can reduce that 1/48 and 3 to 1/16 pi h squared dH dt. Since we're solving for dH dt, let's multiply both sides by 16 and divide by pi h squared. All right? So then we can just plug and chug. So that would be 16 dV dt divided by pi h squared equals dH dt. I find it easier just to isolate your variable when you're not dealing with a bunch of numbers and you're just dealing with some algebraic expressions. Now we can plug in. So we think we said the height was 7, or 7 was the height in the problem here, and we've got negative 120 for dV dt and everything else, and we're just solving for dH dt. So 16 times negative 120 divided by pi times 7 squared equals dH dt. All right, we're not going to do any really reducing there. So because 49 is not a factor of 16 or 120, I'm going to just, I guess, finish up over here. And we'll just write that a little nicer. dH dt equals, and so let's combine. Oh, you know, I lent my calculator, the only halfway decent calculator in here, and I lent it out. And wouldn't you know, now I don't have a calculator. I don't have a single thing that runs. All right, now you got to use the calculator on the computer. It's a good thing I don't have to do too much. Either that or grab my phone. Oh, I can grab my phone. I can reach that one faster. All right. I'm reduced to using the phone. I knew I wouldn't get my calculator back in time. All right, hopefully I get it back. 16 times 120. All right, so negative 1,920 divided by 49 pi. That's the exact answer, and I'm good with it. And that would be in inches? Inches per minute. I'm looking up above to see what the units were. All right, so this is the rate of height, the height of the water is decreasing at a rate of, I don't have enough room to write that in, but it's this right here, when the water level is 7 inches. Right? And so that's what that DHDT means. And that's it. We're done with this one. Ooh, 7 minutes. All right, so I'll see you on the next problem. Bye for now.